All right, so now we're on page 300. We're in the last stretch of our related rates problems. And I will say there are 3 problems on this page, and the first 2 are perfectly routine, things that we've seen before. It's not getting tougher or newer. So pause the video and see if you can give those 2 a fair shot. The third one, you might be able to figure it out. It would take a little bit of extra thought, but you might be able to make some progress on it. All right, so let's take a look at the first one right now. All right, so these 3 are all unrelated to each other. So we've got an airplane flying at an altitude of 5 miles that passes directly over a radar antenna. When the plane is 10 miles past the antenna, the rate at which the distance between the antenna and the plane is changing is 240 miles an hour. This is exactly the kind of thing that radars measure. So it would be really important for the radar operator to know the speed of the plane based on the measurement that they're able to figure it out. Okay, so let's draw a little diagram here. So down here, I've got my little radar tower. I don't know, it looks something like that. And over here, we've got an airplane that looks, yeah, there's the tail and there's the wings. That doesn't look much like an airplane. Oh, well. All right, so we've got this right triangle here because it's 5 miles from the radar to where the plane was flying, and this is where the plane was directly over the radar installation. And since then, the airplane has moved a distance of a miles, and down here we've got the distance between the radar and the plane, which also changes over time. Okay, so what is the relationship between A and D, and what is the rate that we know, and what is the rate we want to find out? Well, we know that the distance between the antenna and the plane is 240 miles an hour. So that's the distance between the antenna and the plane. So that's dd dt is equal to do you think it's increasing or decreasing? Well, the plane is moving further away from the antenna, so the distance should be increasing. So it's positive 240 when the plane is 10 miles past the antenna. So that's when A is equal to 10. And we want to know the speed of the plane. So dA dt is what we're trying to solve for. All right. And what's the relationship between A and T in this problem? Well, we've got a right triangle. So we've got the Pythagorean theorem here. So the relationship is that A squared plus 5 squared is equal to D squared. So we can take the derivative of this with respect to time. And so we have 2a dA dt plus, this is a constant, so that goes away. And over here, we've got 2d dd dt. It's a little bit weird using d as the name of a variable, but I mean, dd dt doesn't mean anything other than the change in distance over time. So that's not a really big deal. Okay, so we want to solve for dA dt, and so dA dt, I'll just divide both sides by 2a. The 2's cancel out, and so we've got d over a dd dt. Okay, and we know that a is equal to 10, but we don't know what d is equal to. So let me draw one of my snapshot views down here. So in my snapshot, that's 10. And this is 5, and so this is d. And so I'm going to use the Pythagorean theorem to calculate what d is. So I've got 5 squared plus 10 squared is equal to d squared. So that's 25 plus 100 is equal to d squared. So d squared is equal to 125, and we'll say that d is equal to, we'll just say the square root of 125. All right, and so now we can substitute in our numbers. So d is the square root of 125 over a, which is 10, times dd dt, which is 240. And so we'll stick this into our calculator. So the square root of 125 divided by 10 times 240 is equal to 268.328. And what's our units for this? We're talking about dAdt. We're talking about the speed of the plane. So we want some sort of unit of speed. So it's a measurement of distance divided by the measurement of time. And so that's miles per hour. Okay, so that was just a pretty routine problem. So that just gives you an idea of how kind of the ordinary run-of-the-mill related rate problem works. So hopefully that's familiar to you. The next one is going to be in the same vein. So give that a shot if you haven't been in the habit of giving these a shot.